Okay, hi guys. Today we're doing section 9.1. So we're in probability. We're reaching the end of our time together in pre-cal. So we're going to spend some time on probability. My whole goal for this is to just get you ready for any discrete math or any basic college level math you may need to take. So hopefully some of this is review. I feel like we do a lot of probability in most of your other math classes leading up to this. And if it's not, hopefully we're just hitting on some important things, so then you'll be able to know them when you get to any college math you may have to deal with. Okay, so what we're going to start with is we're going to start with a basic counting principle. Mostly I'm going to write a problem and then we're going to solve them, and you're going to be able to go back to these problem types later on. This first concept though is called the counting / multiplication principle. And this is where we're taking all of the number of options and multiplying them together. So take number of options and multiply together. Again, I'm hoping to do a lot of examples, so hopefully you can always come back to your notes and find a specific example that looks like something you may see on your homework. So the first one is find the number of possible outfits. Find the number of possible outfits. So I'm going to list certain clothes and how many of each type we have, and you're going to tell me how many unique outfits we can make. So first we'll start with 3 pairs of pants. We'll call them black, white, I don't know, gray. Then we'll have 2 shirts that you can choose from. And we're at Cathedral, so we'll say that we've got white and blue. And then we've got 2 pairs of shoes. Maybe we'll call 1 tennis shoes and 1 sandals. Hope I spelled that right. Okay, so you have 3 pairs of pants, 2 shirts, and 2 pairs of shoes, and so we're going to figure out how many outfits that we can make. The method that we use to solve this is called like a tree diagram. So we're going to make a tree diagram to show how many options that we have. So we're going to start by making a list of the pairs of pants that we have. I'm going to zoom in a little bit. So we have 3 pairs of pants. We've got black pants, we have white pants, and we have gray pants. After that, after you pick 1 pair of pants, you have to pick a shirt. So if I have black pants on, then I have 2 options for shirts, right? White and blue. Same thing for if I was wearing white pants, I still have the option of white and blue. And for gray pants, I still have the option of white and blue. And then from there, for each outfit, whichever tree path you take, you now have 2 pairs of shoes you can choose. Tennis shoes or sandals. Tennis shoes or sandals. Blah, 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 blah. Oh gosh. So from the beginning, these are all the different paths you can take. So you could wear like a white shirt, and then you could wear or a white pair of pants and then a blue shirt and then sneakers. Or somebody else could decide that they want to wear a gray shirt with pants with white shirt and with sandals. So like all of these different options, you can take all of those different paths, those different tree limbs, I guess, to get to where you want to be. And so at the end of the day, we'll see how many outfits that we have. Since we made this tree diagram, we can just count 1, 2, and I'm just counting this final column right here. If you were to follow all of the paths, it would just reach you to this final column. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if we just count them, we know that there are 12 options. However, this is all fine and dandy if I have very small number of options, but if I told you I had 20 shirts and 17 pairs of shoes and some obscene number of pants, you don't want to make a tree table all the time, a tree diagram all the time. So instead, we can just multiply the number of each item that we have and then solve from there. So I can say, okay, I've got 3 pairs of pants times 2 shirts times 2 shoes. 3 times 2 times 2 3 times 2 is 6. 6 times 2 is 12. Is that the same number as I got above? Yes. So you can count or you can multiply. That's why it's called the counting multiplication principle. Who would have thought? All right, now we have another one. This is probability, and it's often with license plate. This is still under the counting multiplication category. So we'll call this a new example though. And this also often has to do with license plates. Sometimes it has to do with like phone numbers. I don't know if I'm gonna do an example like that. I'm gonna do a card example. So like if you have a deck of cards, those are kind of things that we love to do. So these are, some of these things are really important to just start getting the hang of, like how many cards are there in a deck? How many letters are there that we can use? Yada, yada. These are some very basic things that you're gonna see a lot of, and so we just might as well get familiar with it. Okay, so I could say you're getting a license plate, and we wanna know, let me do one more thing. Our restrictions are that you will have 3 letters followed by 3 numbers. I do not know enough about license plate. That's just this situation. I don't know if that's real for all license plates, so don't quote me on that. But our restrictions here are there are 3 letters followed by 3 numbers. So first thing we're gonna do is find the total number of license plate options if there's no limit on if letters repeat or not. So we're just gonna find the total number of license plate options we can have. And so I'm gonna write repeat behind it, which means that you're allowed to repeat, you're allowed to use all letters, all numbers, all of that fun stuff. So there's no other restrictions then besides the fact I've got 3 letters and 3 numbers. So I like to kind of set up a pattern for us. So I know that I'm gonna have 3 letters and then I'm gonna have 3 numbers. How many letters can I choose? Yep, I hear you counting them. 26. There are 26 letters. So if I have no problem with repeating or using all letters, I'm going to do 26 options for the first letter. I also have 26 options for the second letter, and I also have 26 options for the third letter. I can pick any letter A through Z for all 3 of those spots. Okay? Same idea for the numbers, but this time, how many numbers do I have to pick from? The answer is 10. Some of you might have gotten that. Some of you might be like, what do you mean there are 10 numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9. You can't use 10, Miss White, because that's 2 digits. True, but there's another digit we might have forgotten beginning, which is 0. So if you just said 9, you might have forgotten 0. Okay, this is just a little reminder in case you forgot how many single digit numbers there are. And I have all 10 options for all of them. And since this is the multiplication or the counting principle, we're just going to multiply, 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 multiply. All of those together. Throw them in your calculator, and what do you get? You get this number. So I'm too tired to read out loud. And that's how many possible plates we can get. It's a lot of possibilities. Okay, so that's if I could repeat and use all numbers. Now, what if I made a restriction? What if I said you can't repeat any letter? So if I choose like M for the first letter, I cannot have M ever again. Or if I choose 8 for the first letter, I can't choose 8 ever again. So now we're going to do same idea, but now we're going to say no repeating. I'll lose it. Okay. I don't know if it lost it. I'm going to keep going as if it didn't lose it. And I'm going to be mad if I have to retape it. So I'm just giving you a heads up. We'll see later how this video taped. Okay. So again, I'm doing no repeating letters or numbers. We just found the total number of plates. I have no idea if that first half of my video saved, but we will find out later. Letters or numbers. Okay. So I'm still going to have my 3 spots, 1, 2, 3 for my letters, and I have 1, 2, 3 for my numbers. My first letter can be any letter in the whole alphabet, so I do have 26 options there. But let's say I use letter M. Well, I can't use letter M again, so I have to use I can use any letter but that. So now I only have how many options? 25. And then once I use that letter, let's say it's I don't know, a T, then I'm going to, can't use M or T again, so now I only have 24 options. Okay, so you -1 each time. Same idea for your letters. We start with 10, and let's say we use the letter 0. I can't use that, so now I only have 9 options. And let's say I use the letter 1. I can't use 0 or 1, so now I only have 8 options. And so we're going to multiply all of those together. There can be other options where I say you can't use any vowels or you can't use any consonants, and so maybe you won't start with 26, but this is just kind of a basic example to show you no restrictions and yes restrictions. So I'm going to throw this in my calculator and I get out this number. Ooh, this number. And so if I can't repeat any, now I only have 11 million plates, possible plates, not 17. So that changes it. Still a lot of options, but definitely less than there were before. Okay, another way that we can do this counting or multiplication principle is with cards. There's a ton of examples with cards. I don't know how many exactly I'm going to get to today, but they're going to keep coming up. So don't get sick of them yet. So we're going to find out the number of ways to pick one card from a deck of, or number of ways to pick cards, I guess. Number of ways to pick cards. So first, how many ways can you pick one card from 52? Blank ways to pick one card from a deck. Even if you're not a card shark, you should know that there are a total of 52 cards. So there are 52 ways that we can pick one card from a deck of 52 cards. Now, what if we're playing, like doing a card trick, and I have you draw a card and then I have you draw another card? You didn't put the first one back in, you're just taking another one right out. It's very similar to what we were just doing with the license plate. So we're going to pick 2 cards, and there's going to be no replacing. So you're keeping both of them in your hands, and you're not putting them in the deck, back in the deck. How many options do you have for the first card that you pick? Well, none of the cards are picked yet, so there's all 52 are sitting there in your hand. And then you grab one, and then you go to grab a second one. How many are left? 51, because you didn't put the other one back in. Again, multiplication property, so we're going, or principle, so we're multiplying those two together. It becomes 2,652 ways to draw 2 different cards. Okay. Now, cards are very interesting, and we're going to introduce a new concept, and we're going to use this with other card examples or in the future to do more probabilities. So this was all multiplication principle. Now we're going to talk about something called a factorial. Have you guys heard about factorials before? Okay, I don't remember. A factorial is a sign, it's a symbol to represent multiplying different things together. So normally it's represented as an exclamation point, or you can also call it a bang. So an example you may see is if I do 5 factorial, it would be 5 exclamation point or 5 bang. Those are a couple different ways to say the same thing. And that means that you're taking the number that you see and then multiplying it by every number after it until 1. So I'm going to do 5 times 4 times 3 times 2 times 1. I don't want to go to 0, because if I multiply all of those and then multiply by 0, it's always going to be 0. So that's not a unique number. These are unique. 5, 4, 3, 2, 1. That becomes 120. If I do 4 factorial or 4 exclamation point or 4 bang, 4 times 3 times 2 times 1 equals 24. Now there's a way to do this in your calculator, so I will either do a calculator version in the next day or 2, or I challenge you to find it. I believe it's under math, and then there's a menu called probability. That's going to be super helpful for us in the next couple days. So if you have never played with math and then go over to probability, I would check that out. Or come call me on Zoom or something like that so I can help you figure it out. A general way that we write factorials is n bang or n factorial or n exclamation point, and that's the number times the number minus 1 times the number minus 2 all the way down forever and forever until you get all the way to 1. And then 2 more examples that are pretty common. If you do 1 factorial, that's just the same thing as 1 because there's nothing else to multiply it by. And then 0 factorial is also 1. Okay, so that is an important thing to know. So we're going to use factorials in the future in these next couple types of problems. So now we're doing some selections. This is where order matters or order does not matter. Okay, so if we are doing, this next word is important. It's called a permutation. Permutation is where order matters. It matters what you pick first, what you pick second, what you pick third. A good example of this is if you're running a race, the first person who wins gets gold, the second person who wins gets silver, the third person who wins gets bronze. It's not just the top 3 winners get the same thing. Like, it matters if you get first, that's a different prize than if you get third. So this is where order matters. Okay, so we call this like an n object in an ordered, again, order matters, an ordered arrangement. So we're placing things in order, and order matters. Okay. If you're just putting things in a linear arrangement, so if you're just ordering it like 1, 2, 3, 4, we'll go one of these guys. You just usually do the number factorial. Okay. Hopefully we'll look at an example. If not, when you get to your homework, you'll see something that you're putting something in a linear order, like you're ordering 5 books in a row or something like that. The next one is if you have a circular order, if you're putting something in a circle, then we can do n minus 1 factorial. Oh, go away. Thank you. And then the more common one you're going to see is letter permutation. So we're ordering letters in certain ways. And I would think that you've seen this before, but if you've never heard of factorial, then you maybe haven't seen this before either. It's a little formula, essentially, you'll see. There's a way to do this in your calculator. There's a button that says NPR, just like this. But what that means is you're doing n factorial divided by the total minus how many sets we're taking, the small group factorial. So you're taking the total and then you're dividing out the repeats, essentially. That's what this thing represents right there. All right, so let's do some examples. First example is it says, how many ways can 5 books be lined up on a shelf or put in order? How many ways can you arrange, or can 5 books be lined up on a shelf? Oop, out of space. On a shelf. This is an example of the linear one because you're just putting it in a straight line. So if I have 5 books, I've got 5 spots, 1, 2, 3, 4, 5. If I take those books, how many options do I have to pick for the first book? You have all 5. You haven't picked any books yet, so you've got 5 options. Well, now you've got that book in order, so now how many do you have for the next one? 4. Now you've used those 2 books, and so for the third book, we have 3 options. Now that we've used the first 3 books, we only have 2 more options left, and then last we're left with 1. So 5 times 4 times 3 times 2 times 1, that's just the same thing as 5 factorial. So that's why up here I told you linear is just n factorial. If we see that there are 5 books, you can go directly to there being 5 factorial options. And we learned a minute ago that that was 120 ways. All right, let's keep rolling. Another example. This time, we are not using all of the books that we have. This is how many ways can 3 books be placed on a shelf if chosen from a selection of 7 books? So let's say you're in the library or at a bookstore, and you're trying to display only 3 books of 7 books that you have as an option. So how many ways can 3 books be placed on a shelf or on display? Whatever makes you happy in our pretend example. If chosen from selection of 7 different books. So this time we don't get to do all 7, we only get to pick 3 of them. So I'm going to show you how you can think of this by hand. So I think it's easier to think it by hand than plugging it into formulas, but whatever floats your boat. Okay, so if I have these, I have 3 books that I can put on display. How many options do I have for the first book? I have 7. I have 7 books to choose from. I get to pick 3 of them. So the first book, I have 7 different options. Now that I've used that first book, I've used one of my 7, so I only have 6 left to choose from. Now I've used 2 of my 7, so I only have 5 left to choose from. So technically what I'm doing is doing 7 times 6 times 5, and that is 210 ways. Now, if you want to put into our notation, we can do it NPR. So NPR, N is the total number, or it's always the bigger number. So we have a total of 7 books. We're doing a permutation of 3 of them. So 7P3, you can think of that as like the 7 exclamation over 7 minus 3 exclamation, which is 7 factorial over 4 factorial. You can plug this into your calculator. Again, if you don't know how to do that, maybe I'll make you a video for today or for tomorrow. Or you can plug this into your calculator. Or you can do 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1. Or you can do it by hand, which I think is the easier way. And those give you the same answer. Okay, so a bunch of different ways to get to the same answer of 210 ways to order those books. All right. So I'm going to give you a couple examples if you want to try and put it in the calculator. I truly think you've seen this before. If I am wrong, please, please, please tell me. I don't want to teach you something that you've already known. So we're going to put it in the calculator. I'm not going to pull the calculator up on the screen for right now, but if you go to math, and then it gives you the 4 different table options, I want you to scroll over to PRB. And then if you go to number 2 on that, it's called NPR. And so we're going to end up clicking that. Before you click that, though, you have to enter in the number, and then you have to type in NPR, and then you have to type the other number. So whatever N is the first number you type, and then whatever R is going to be the second number you type. So if we were doing the example from before, we would have plugged 7, math, probability, 2, and then 3. I'm going to put a couple examples. I'm going to give you the answers. You're going to try it on your own. And if you need help, you're going to call me. So the first one is 4P3. The second one is 10P7. And then the third one is 8P3. So pause, try this on your own. Okay, welcome back. 4P3 is 24. 10P7 is this number, 604,800, I think. And then the last one's 336. Okay. If you have trouble with those, please let me know. Okay. We can also do permutations, not just with like ordering books or ordering classes or putting things in order. I can also give you with letters. I can tell you rearrange the letters in these words. So we're going to do a couple examples of those so you aren't blindsided by that later. the end of this page. So this is called letter permutations. So we're repeating and arranging letters essentially. Okay. So I could give you an example that just says, find the numbers of ways to arrange the letters. Find the number of ways to arrange the letters in these words. And so like, we'll start easy. We'll say the first one is house. So we're going to find all the ways to arrange those letters. This is just an NPR. How many total letters do we have? 1, 2, 3, 4, 5. 5. This would be 5p. We're choosing all 5 of them, which would end up being 5 factorial, which we know what that is. I could also give you ball. In this case, if I have the letter L, I am already repeating the letter L, so I don't want to type that in twice. So if house had all independent letters, so that was just 5 factorial. If I have ball, I have a total of how many letters? 4. So we'll do 4 bang. And then we'll do each letter on how many times we can arrange it. So B, how many of those do we have? We only have 1, so I'll do 1 bang. A, how many A's do we have? Okay, 1 again, bang. And then L, this time we have got 2 L, so we're gonna do 2 bang, okay? And that gets me down to 12 ways. All right, and then last one, we'll do a little longer word. Do some Hoosier pride, we'll say Indiana. Because there's some repeaters in here. So how many total letters are there in Indiana? 1, 2, 3, 4, 5, 6, 7. 7, bang. All right, now we'll go with I's. How many I's do we have? Okay, 2 bang. How many N's? 2 again. How many D's? 1. We already did I's. Did we do A's yet? Nope, 2. Perfect. And so if you throw that all in your calculator, then that's going to be 630. Also, these could be simpler to write. Like 1 bang, 1 bang, 2 bang is 1 times 1 times 2 times 1. That's just 2 in the denominator. Okay, that's not too hard. Same thing down here. 2 factorial, 2 factorial, 1 factorial, 2 factorial is just 2 times 2 times 2, which is 8. So like these denominators can get pretty simple pretty quick. So this will become 2 and this becomes 8. So just because you see all of these like symbols in the denominator, I would probably simplify it before you throw it in the calculator, or else you're probably going to mess something up because you do not have the right, parentheses or something like that. Okay, the last thing that we're going to talk about is combinations. I'm actually just going to put this on here so I can make this all one page. All right, so we're going to talk about combinations. Combinations are where order doesn't matter. So often we talk about combinations versus permutations. Combinations is where order does not matter. Permutation is where it does matter. So combinations. Order not matter. Okay. Just like we have NPR, we have something called NCR, and it's right next to it in the calculator. This time we do the total factorial on top, and then we do the repeats n minus r factorial, and then we also multiply it by r factorial. Multiplying it by r factorial gets rid of the importance of order, so it cancels out the importance of order. Cancels the importance of order. 90% of the time you'll do it on the calculator, so it's not that big of a deal. Words that might tip you off, we're going to say that we selected or things have been chosen. And also it matters, or I guess like a phrasing that you may see is that it doesn't matter like who's first, second, or third. So like, let's say if you're, again, I guess running a race and they say the top 3 people move on to sectionals, Well, it doesn't matter if you were placed 1 or 3, you're still moving on to sectionals. You don't get a different prize. You're not getting gold, silver, or bronze. You're just all 3 moving up to sectionals. Okay. So we're going to do a couple examples again here, just so you have some to base off of before we go. Okay, so let's say an example I'm going to give you is we're going to say how many groups of 5 students can be chosen from a class of 25. I use the word chosen again. There's no difference in if you're the first one chosen or the last one chosen. You're still all in the same group. So this one, we can use our NCR again because I see the special word chosen. That tips me off. How many total people can I choose from? 25. And how many do I get to choose? 5. Now, I'm sure I learned this by hand one time, but I don't remember exactly how you put it out by hand like I did with permutations. So your best bet is to put in the calculator, or you can think about putting it in the form like I said before. The n goes on top, n minus r factorial times r factorial goes on bottom. Again, you can simply put that in the calculator or the actual equation, and you're going to get out 53,130 different groups. It's a lot of different groups. Okay, that's one example. Let's do another one. Another thing we often do with these kind of probability problems is marble. So you're going to see some marble problems on homework and on notes in the future. So we're going to say that we have a box and it contains 12 black marbles and 8 white marbles. And I could ask you a billion questions about these, but we'll just say, how many ways can 3 black and 2 white be chosen? It does not say 3 black and then 3 white. It just says, if I reach in, how many ways can I get 3 black and 2 white? Okay, this is a combination of my combination type, my choosing, and my multiplication property that we've been doing kind of all day. We'll do our n choose r, NCR will be how many black marbles are there? Well, there's 12 and we're choosing 3. And then same thing for the white. Well, there's 8 and we're choosing 2. Again, literally put those 2 in the calculator. If you put them in separately, you'll get 220 and you'll get 28. And again, we're multiplying because that's what we've been doing this whole time. And we get 6,180 ways. Again, I could ask a billion questions, but if I just simply ask how many ways can we choose this many and this many, we just do this example, okay? I'm going to give you some examples for homework. Try them out. Let me know if you need any help. And good luck. Bye.